Stop looking at those glossy, utopian renders of lunar cities you see on the news. They are selling you a fantasy. The reality of the moon isn't a dream. It is a graveyard waiting to be filled. If you stepped out of the airlock today, the silence would be the first thing to hit you. But it's the environment that hunts you. This is a world of violent extremes, a silent tomb where the temperature doesn't just fluctuate, it snaps. We are talking about swings from a scorching 250 degrees Fahrenheit in the sunlight to a bone-shattering minus 208 degrees the moment the shadows fall. In a single cycle, metal expands until it warps and then contracts until it shatters. But the heat and cold are manageable. They are predictable. Your true enemy is something much smaller and infinitely more dangerous. The dust. On Earth, wind and water erode sand into smooth, round spheres. But the moon has no wind. It has no water. So, the dust remains exactly as it was when asteroids smashed it into existence billions of years ago. Microscopic, jagged shards of razor-sharp glass. It is electrostatically charged, so it clings to everything. It finds its way into the tightest mechanical seals. It shreds spacesuits like sandpaper. During the Apollo missions, it clogged joints and gave astronauts lunar hay fever after just a few hours. And yet, this hostile, abrasive hellscape is exactly where China is betting its entire national prestige. They don't just want to visit, they want to conquer. The International Lunar Research Station, or ILRS, is an unprecedented gamble to build a permanent industrial civilization right in the middle of this abrasive wasteland. This isn't just about planting a flag anymore. This is about survival. This is colonization. But the question the media isn't asking is this: is our technology actually ready to fight a war against physics itself? Or is China simply building the most expensive tomb in human history? Here is the logistical nightmare that kills most space dreams before they even leave the launch pad. The tyranny of the rocket equation. To build a city, you need thousands of tons of steel, concrete, and glass. But in spaceflight, weight is the enemy. Historically, shipping a single kilogram of payload to the lunar surface has cost upwards of $1.2 million. Even with SpaceX's Starship promising to slash those costs, shipping a single brick from Earth to the moon would still cost more than its weight in solid gold. This economic reality forces China into a corner. They cannot bring their city with them. To survive, they have to use what is already there. They have to build their future out of the dirt beneath their boots. This is what NASA calls ISRU, in situ resource utilization. But the dirt on the moon isn't like the soil in your backyard. It's regolith, a dry metallic powder composed of silicon dioxide, iron, and calcium. Other YouTube channels might lazily tell you that China will simply 3D print buildings and leave it at that. But let's break down the engineering reality, because it is far more complex than squirting plastic out of a nozzle. You cannot use traditional concrete. Concrete requires water to cure and harden. On the moon, in a near-perfect vacuum, liquid water doesn't just evaporate, it violently sublimates, turning instantly into gas and exploding outwards. Any standard wet cement mixture would crumble into dust before it ever set. So, how do you build a fortress without water, cement, or glue? China's solution is a process called laser sintering. The plan involves deploying a fleet of autonomous, solar-powered robots equipped with high-intensity optic lasers. These aren't just piling up dirt. They are fundamentally changing the chemistry of the ground. Here is how it works. The robot smooths out a layer of regolith. The laser fires, heating the dust to nearly 3,000 degrees Fahrenheit. At this thermal tipping point, the microscopic grains of glass and metal don't just stick together, they melt and fuse at a molecular level. As the laser moves, it leaves behind a trail of solid ceramic-like rock. Layer by layer, the robot prints a structure that is arguably stronger than terrestrial concrete. But what shape do you print? You can't build a square house on the moon. On Earth, we build with sharp corners because the air pressure inside the house is the same as the air outside. On the moon, the outside is a vacuum, the inside is pressurized with oxygen. If you built a square room, the internal pressure would blow the walls out like a balloon, focusing stress on the corners until they crack. This is why China is proposing the moonpot vessel design. Inspired by the physics of an eggshell, this structure uses continuous curves to distribute internal pressure evenly across the entire surface. It features a clever double-shelled architecture, an outer shield to absorb meteorite impacts and radiation, and an inner shell to hold the atmosphere. On paper, it is a stroke of architectural genius. It is light, it is strong, and it is theoretically printable. But in practice, this is where the skepticism kicks in. We are talking about using high-precision optical lasers, instruments that require clinical cleanliness, in the dirtiest environment in the solar system. Remember the dust we talked about? It is electrostatically charged. It doesn't just sit on the ground. At the terminator line, where day meets night, the changing electric fields actually cause the dust to levitate, floating up from the surface in a ghostly, abrasive cloud. Imagine trying to keep a precision laser lens clean in a sandstorm that never ends. If a single layer of dust settles on the focusing lens, the laser won't melt the ground. It will heat the dust on the glass, shattering the robot's own optics instantly. There is no geek squad on the moon to come fix it. If the printer jams, the construction stops. If the lens cracks, the mission fails. This is the fragility of the Chinese plan. They are relying on a level of automation and durability that simply does not exist yet. They are trying to perform open-heart surgery in a coal mine, and that is the engineering bottleneck that keeps the scientists in Beijing awake at night. Building the shell is the easy part. Any engineer can design a pressure vessel, but keeping the lights on, that is the real nightmare. Here is the brutal reality of orbital mechanics. The moon is tidally locked. A single day lasts a month. This means that for 14 Earth days straight, the sun beats down relentlessly. But then, inevitably, the sun sets and it stays set. For 2 weeks, 336 hours, you are plunged into absolute pitch-black darkness. Without the sun, temperatures instantly crash to minus 208 degrees Fahrenheit. Your solar panels? They become glorified paperweights. On Earth, we survive the night with batteries. But to survive a 2-week lunar night on lithium-ion batteries alone, you would need to launch a battery bank, the size of a cruise ship. The physics just doesn't make sense. So, China has only one option left. To survive the long night, they must go nuclear. The plan is to deploy a compact nuclear fission reactor by 2035, a heartbeat of heat and electricity that never sleeps. And this is where the plan stops being an engineering challenge and starts being a geopolitical gamble, because China isn't building this reactor alone. Their key partner for this critical infrastructure is Russia's state nuclear corporation, Rosatom. On paper, this makes sense. Rosatom is a global titan in nuclear energy, but there is a massive difference between building a power plant in Siberia and landing a reactor on the moon. Let's look at the track record. China is betting the lives of its future astronauts on the Russian space industry. But the Russian space industry of today is a ghost of its Soviet glory. It is plagued by corruption, brain drain, and underfunding. We saw the proof in August 2023, the Luna-25 mission. It was supposed to be Russia's triumphant return to the lunar surface after 47 years. It didn't just fail, it lost control, spun into an erratic orbit, and slammed into the lunar surface, disintegrating upon impact. This catastrophe sent shockwaves through Beijing. Think about the implications. Russia couldn't land a simple, uncrewed robotic probe. Yet, China expects them to safely deliver a heavy, highly volatile nuclear reactor to the same spot in just a few years. This is the single biggest point of failure in the entire ILRS project. If the solar panels are useless in the dark, and the Russian reactor crashes on arrival, the base dies, the heating systems fail, the air recyclers stop, the water reclamation units freeze solid. China is attempting the most ambitious construction project in history, but they are building it on a foundation of crumbling alliances. Is China really willing to bet the survival of its colony on a partner that can barely stick a landing? Or will they be forced to cut Russia loose and develop the technology alone, delaying the project by decades? The clock is ticking, and the lunar night is waiting. But we cannot talk about China's ambition without looking at the elephant in the room. The United States. For the first time since the 1960s, we are in a true space race. But this is not a repeat of Apollo. Apollo was a sprint to the finish line. Once the flag was planted, the Americans went home. This time, both sides are playing for keeps. Look at the map. Both NASA's Artemis program and China's ILRS have targeted the exact same real estate, the Lunar South Pole. Why? Because that is where the water ice is, and whoever controls the water controls the fuel station for the rest of the solar system. But their strategies could not be more different. The American strategy is a coalition. Through the Artemis Accords, the US is trying to build a NATO of space, bringing Europe, Japan, and Canada along for the ride. It is diplomatic, it is open, but it is slow and messy. China's strategy is a fortress. They are building a closed loop, vertical integration. They don't want a coalition, they want a tributary system where they set the rules, the standards, and the time zone. Here is the cold, hard critique. The US suffers from ADD, attention deficit disorder. Every time a new president enters the White House, NASA's direction changes. They cancel rockets, they shift budgets, they lose momentum. China does not have that problem. The plan they wrote 10 years ago is the plan they are executing today. They have the terrifying advantage of consistency. So ask yourself, who would you bet on? The chaotic innovator, relying on the volatile genius of Silicon Valley, or the relentless machine that plans in decades, not election cycles? The moon doesn't care about your politics. It only cares about who shows up and who stays alive. Let's assume the tech works. Let's assume the laser printers build the walls, and the Russian reactor actually turns on without exploding. We need to talk about the cargo, the biological component of this machine, us. What does life actually look like for the first generation of lunar citizens? First, erase every sci-fi movie you have ever seen. There will be no glass domes overlooking the Earth. There will be no skylights. On the moon, a glass ceiling is a death sentence. Without an atmosphere, the surface is constantly bombarded by galactic cosmic rays. High-energy particles, traveling near the speed of light, they tear through glass, through metal, and through human DNA like invisible bullets. Living on the surface would riddle your body with cancer in a matter of months. So, China's long-term plan is not to build up, it is to dig down. They are targeting lava tubes. These are massive, hollowed-out arteries formed by ancient volcanic rivers billions of years ago. Some are wide enough to fit an entire city inside. This is the future of humanity. We are becoming troglodytes, cave dwellers. Imagine, you are a Chinese colonist in 2040. You wake up in a bunk the size of a coffin. You step out into a habitat buried hundreds of feet under millions of tons of basalt rock. You are safe, yes. The rock protects you from radiation and meteorites, but the psychological toll is unprecedented. We evolved for millions of years to sync with the rhythm of our planet. The rising sun, the changing wind, the smell of rain, the color blue. Down there, all of that is gone. You will live in a world of absolute sensory deprivation. The light is artificial, LED. The air is recycled and smells of sweat, ozone, and metallic dust. There is no weather. There is no horizon. This is where the real danger lies. It's called the break-off phenomenon, a state of dissociation reported by high-altitude pilots and polar researchers. When you are completely isolated from the Earth, when you can't even see it in the sky because you are underground, your brain starts to detach from reality. Space psychologists warn that cabin fever, in such a hostile environment, doesn't just make you cranky. It breeds paranoia. It feeds depression. In a submarine, sailors can surface after 6 months. On the moon, there is no surfacing. You are trapped in a stone tomb 240,000 miles from the nearest breath of fresh air. A small argument over a spilled ration pack can escalate into a murderous rage when there is nowhere to run. China talks about the Moon City as a triumph of engineering. They treat humans as just another interchangeable component in the system. But history has shown us that while machines work better in a vacuum, human minds do not. We might have the hardware to keep human bodies alive, circulating blood and oxygen. But do we have the environment to keep human minds sane? Or will the first colony on the moon eventually descend into madness, buried in the dark, screaming where no one can hear them? China's plan to urbanize the moon isn't just an engineering project, it is the most aggressive play for dominance. In human history, we are talking about the boldest feat since the pyramids, but with stakes that are infinitely higher. If Beijing succeeds, they don't just get a science lab. They secure the ultimate strategic high ground. They unlock the trillion-dollar energy reserves of helium-3 and become the first true interplanetary superpower, leaving the West stuck in low Earth orbit, looking up in envy. But ambition is cheap. Physics is expensive. The gap between a glossy CAD drawing and the gritty, lethal reality of the lunar surface is 240,000 miles of deadly risk. The moon is indifferent to our politics. It does not negotiate, and it does not forgive mistakes. We stand at a fork in the road of our species. Look up at the night sky tonight. Are we witnessing the dawn of a new civilization? Or are we watching the construction of the most expensive, abandoned ruins in history? Silent, dusty monuments to human hubris that will outlast us all. I want to hear your verdict. Is humanity actually ready to live in the radioactive dirt of another world? Or is this just a desperate attempt to run away from the problems we created on Earth? The comment section is open. Let the debate begin.